this is just a quick narrative of where I'm at making an enclosure here for revision E of the CO2 board. So here on the left we see a snapshot of it. This is what it looks like when it's not populated. These are the ingredients here. There's a Wi-Fi LoRa module, an ambient pressure module, a microphone, and the CO2 sensor itself. Those get populated on the board, and the result looks like this. And I'm also going to see if I can show this on the screen. I can't actually see what I'm showing, but just to say, this is the device, and this is how thick it is. So when making an enclosure, we have to figure out a way to mount this inside so that the USB and the buttons are accessible. And what you don't see in the photos, and what I can show here, is that additionally there is a rechargeable battery, and so that gets plugged in to the bottom of the board, the bottom of this circuit board. And the idea is that that will sit below the PCB, so that when this PCB is mounted in the enclosure, the battery will be below it. So I'm imagining screws here at the corners that have standoffs that keep the PCB sufficiently high above the bottom of the enclosure that it can accommodate this battery below it. So this is my first attempt at doing that, and so this is an OpenSCAD, and because I don't quite know what I'm doing here, I just made an enclosure where the screen of the device is accommodated by this gap here. The microphone is accommodated by this circular gap. The buttons on the sides are accommodated by these two holes, and then the USB port is supposed to line up with this gap here. And in terms of the overall size of the enclosure, without being very sophisticated about this at all, the idea here is that the PCB sits about halfway down here, and then there might be some way of using standoffs to keep it high enough above the bottom that the battery can sit below it inside the enclosure. So that's where I'm at with the enclosure. Furthermore, just to show the way I've got this separated into cover and bottom of enclosure, right now I'm rendering both the top and the bottom. If I render only the top, I will comment out this part, and we see the cover part here. I've just subtracted a cube from enough of a gap below, and then let's do the same for the bottom. So there we go. Now we've got the bottom, and I currently don't have what might make sense is to have some material inside here that essentially just provides a cavity for the battery below, so that there's a thick amount of material for the screws and the standoffs to screw into. I'm still a little bit anxious that I don't have the spacings exactly right. So for right now, I think it might be acceptable to just have screws that go through the bottom cover if this material thickness isn't enough to handle a screw. So for right now, I'm going to render all of it. Sorry for that weird effect there. And I just also wanted to show that I don't quite understand how I'm dialing in wall thickness. I do have a parameter, so I believe the code that I am working off of essentially, I think, makes a cube and then subtracts out another cube inside of it, and then also interacts with a sphere in order to make these rounded edges. And I sort of haven't dug into the code enough to understand exactly how that works. But when subtracting out that inside cube, there is a parameter that I'm using, wall thickness, that doesn't quite work the way I would expect, but I can impact the wall thickness. So right now it's set at -1, which clearly is a bit odd, but if I set it to -2 and render, then it gets a little thinner, and -3 thinner still. So I'm not exactly sure what's going on here, but it should be clear to anyone who knows OpenSCAD what's going on here. And finally, a quick overview of the structure of this. I'm defining some parameters in the beginning, and then that have to do with the location and the size of the gaps in the enclosure and the overall size of the enclosure. And then there's a module enclosure that is defining the overall enclosure and the spacing inside, and that's from here to here. And then there's a module enclosure holes that is the union of the holes that pass through the enclosure. And then there's a module concat that just takes the difference between those two in order to generate the holes inside the enclosure. And so then if we wanted to render all of that together, concat, then you would just call that module concat. Instead here, I am doing a difference between the entire enclosure and a cube that subtracts out the bottom when I want to render the cover. So that's what I'm doing here. And then when I want to render the bottom, I'm doing a difference between the entire module concat and then a cube that wipes out the top. So that's just an overview of the code there. Okay,